So now we're on to part 2 of 5.2, which is talking about inverses. Now we did inverse functions at the beginning of the year, and I showed you how to find the inverse, and that's what we're going to do today. So we need to remember how to do this. So the first thing we do when we find an inverse of a function is we switch x and y, and we solve for y. So what we need to remember with logarithms and exponentials is since they are inverses, they can cancel each other out, okay? Other things to remember, log, I mean, you don't see base, is a log base 10, and ln is the log of e, or log base e to the x. So we also want to remember that we can switch or rewrite the form to exponential if we need that. Okay, so let's look at an example right now of how to do inverses. So here's an example with some directions. So we have our function. Now, if it's in f of x, make sure to change it to y because we're going to switch those y's and x's, right? So our next step here is to substitute each x with y and each y with x. So as you can see right here in the original, I have y equals ln of x plus 2 minus 3. So now here, instead, when I switch, we're going to have x equals ln of y plus 2 minus 3. Now, what are we going to do? Well, our next step is to solve for y, get y by itself. Okay, so here is how we're going to do that. We're going to undo. We're going to do inverse operation to get y by itself. So the first thing it looks like is I need to get rid of this minus 3 before I can get rid of this ln. Okay, because it's on the outside, so I have to move it over. So how do you get rid of the minus 3? Well, we add 3 to both sides, right? Okay, now we can open this present up and get to the y, right? We have to get rid of the ln. We get rid of the ln because of the inverse function. What is the inverse function of ln? Well, the inverse function of ln is e. So what we're going to do is e both sides. When we e the left side, the x plus 3 becomes an exponent, so make sure it looks like it. And then e and ln then would cancel, so we're left with, on the right side, y plus 2. Now we're still getting y by itself, so we need to move that 2 over. We move that 2 over by subtracting it from both sides. And then, of course, when we find inverses, we usually define them as f to the negative 1. Okay, so make sure when you're writing, because again, right here, when we e both sides, that x plus 3 becomes an exponent, that it's up a little bit more, so you know it's an exponent. And we'll go through some of these examples, and you'll see how the writing gets a little tricky. All right, example 1 here, we're going to switch. It's already in y equals, so we're going to switch our x and y. So we get x equals log base 3 of 2y plus 1 plus 5. Okay, now we're going to get y by itself. Before I can get rid of log base 3, I have to get rid of this extra on the outside here of that 5. How do I get rid of that 5? I subtract it from both sides. So on my left side here, I get x minus 5 equals log base 3 of 2y plus 1. Now, to get rid of the log base 3, well, exponential, when I think of exponential, what is the base? The base is 3. So I'm going to write in another color so you can see how I write this. So to get rid of log base 3, I have to have a base 3, right? That exponential. Well, whatever I do to one side, I have to do to the other. And now this x plus 5 becomes an exponent. So when I rewrite this, so you can see how to rewrite it, I get 3 to the x minus 5. I want to make sure that looks like an exponent, okay, equals. And what happens here is that this log base 3 and this base 3, they cancel because they're inverses of each other, leaving us with 2y plus 1. Now I want to make sure I have room for later on, so I'm going to move this over to the side, because now what is my next step to get y by itself? I have to subtract 1 from both sides. So that's what I'm going to do now. So 3x minus 5, I'm subtracting the 1. Now you see how that looks different? That -1 or -1 is not in the exponent, and I can obviously see these are two different areas, so be careful. Leaving us with 2y. Okay, how do you get y by itself now? We divide both sides. So we have 3x minus 5 minus 1 divided by 2 equals, and we're left with y, right? But of course, we're showing this as inverse. So I'm going to say f to the -1 of x. And we did it. So inverse operation. Let's do our next one, because this is a little bit different than our question above, right? Okay, I see I have we're in y's. So next I'm going to switch my y, my x. So I get x equals 5 to the y minus 6 plus 1. Can I get y by itself? Now y is in the exponent, which means I have to get rid of that base 5. But before I get rid of that base 5, I have to move that 1 over, because that 1's not in that present, that package right there. So I have to move that 1 over first. Move that 1 over by subtracting. Okay. Now, how do I get rid of that base 5? Because I need to bring that y minus 6 down. Well, to get rid of a base 5, what we do, because remember the inverse of base 5 is log. Okay. And whatever we do to one side, we have to do the other. Now, one thing I want to point out here, and I know it's based on how it's writing, this is not an exponent. What I'm doing is these two are going to cancel each other out. We have to remember that when we log both sides, that it's on the same level. It's not an exponent. I also want you guys to keep in mind that right here, if I kept it just like this, it looks like log base 5 of x, but it's log base 5 of x minus 1. So I want to make sure I have parentheses around there to show that 1 is in the log. All right, so let me rewrite what I have right now. We have log base 5 of x minus 1 equals, and because these two cancel, the exponent is now down below, which is y minus 6. And how do you get y by itself now? You add 6 to both sides. So our final answer is a log base 5. Make sure it's in parentheses, x minus 1 plus 6 equals, no, of course it equals y, but we're going to show that this is an inverse. So I do f of -1. Again, making sure that parentheses right there, because otherwise you'll combine the 6 and the -1. And this 6 is not part of the log. One more, and we'll see what you can do on your own, okay? Because I want to get into these ln's and e's because they come up, right? So we're in y equals, so let's rearrange this. not rearrange, switch x and y. So e to the 2y minus 6. Okay, that y is in that exponent, so we got to get rid of that e, that base e. But I need to get rid of that minus 6 first because it's on the outside there. So how do you get rid of that minus 6? Well, we add 6 to both sides. So I have x plus 6 equals e to the 2y. All right, up here in example 1 and 2, we were talking about logs and bases and how they cancel, right? Log base, let's say 7, cancels out a base of 7. Well, now we have e. What cancels out e? ln, right? ln and e are inverses of each other. So I have to, and let me do this in another color so you guys see, ln both sides. Now, of course, this doesn't make it an exponent. It's just because of the writing. So when I ln the whole thing there. So I'll put my parentheses in there. And I do this because e and ln are inverses, so they cancel. So let me rewrite what I have. I have ln parentheses x plus 6 equals 2y. How do you get y by itself now? Divide by 2. So our final answer is ln of x plus 6 all over 2 equals f of negative 1 of x. There we go. We have to learn how to solve for these things. We'll have more practice a little bit later, because when we get to real life situations and you talk about exponential happenings in real life, right? We have to solve sometimes for the exponent. So we need to know how to rearrange things and cancel things out. So when you get to your science classes and you talk about bacteria exponentially growing at what rate, all of these ideas come into play. All right, let's see what you can do on your own. Ask for help if you need anything.